Okay, so we're recording here. Okay, so we're going to look at number 6 here. So we're interested in the magnitude of this vector. So I'm just going to write down, what I'm going to actually write down is magnitude squared, because it's easier than writing down magnitude because I don't have to deal with square root. We'll take the square root at the end if necessary. Okay, okay, so the magnitude squared of that vector is, okay, well, it's the sum of the squares of these two components. Well, the components are n squared minus m squared and 2nm. Is that cool?
Mm-hmm.
Okay. Okay, all right, so let's multiply this all out. All right. So this is n to the 4th minus 2 n squared m squared plus m to the 4th. Is that cool?
Mm-hmm.
Okay. All right, that is, well, let's see, it's 4 n squared m squared. Yeah? Everybody good so far? Okay, now good news. These two terms are a lot alike, right? So there's a common powers of n and m, and so I can just combine those together, and what I get is altogether then n to the 4th. Oh, I have a minus 2 and a plus 4, so that gives me plus 2 n squared m squared plus m to the 4th. Yeah? Okay, now let me make the observation now that this quadratic, or this, whatever you want to call this thing, this sort of multiplied out thing came from this, square of n squared minus m squared. And then notice that these two things look kind of alike. The only difference being that that minus sign here is now a plus here. And so the suggestion is, this is kind of, maybe this is where you got stuck before, but in the same way that simplified like that, this I can simplify as n squared plus m squared quantity squared. It's sort of an analogous algebraic. Everybody good with that?
Yep, that's it.
Okay. Yeah. Okay. So this. Yeah. So I'm guessing that's probably where you got stuck in your algebra previously, and it's just this sort of clever sort of realization. Oh my gosh, it changed. I mean, this thing here, it changed my expression here, but it really all it did effectively is change a minus to a plus. Mm-hmm. It's kind of cool. You'd be surprised how often this particular little algebraic trick shows up. Right, and okay, so that was, now you'll recall, that was magnitude squared. We were asked to compute magnitude, so the magnitude of the thing we're interested in is then the square root of this thing, which is just n squared plus m squared, and that is an integer.
Is there anything formal we need to do to prove that n squared and plus m squared?
Nah, I think for these purposes, if this was a some sort of a proof class, then yeah, maybe, but it's pretty clear. Yeah, exactly. because n and m are integers.
Exactly.
So, yeah, right.
So.
Okay.
Yep. Are you happy?
Yeah, definitely. I just wanted to be sure that was an acceptable answer.
Oh yeah, totally. Yep.
Okay,
Yep.
that's awesome. Perfect.
Okay,
Thank you.
great.
You can.
All right.
Good. I was like,
Good. Okay, let me just stop the recording here.
Thank you very
Or do you have a
much.
question about this? Okay, yeah, 2 seconds.